what happens when you have an ionic compound. So I have sodium, and it has lost an electron, so it has a plus charge. It gave that electron to chlorine, so chlorine has a negative charge. If I have +1 and -1, what's the overall charge? Neutral. It's 0. So what happens when you make an ionic compound is it is a neutral compound because these should balance out. So if you actually counted these, 1, 2, 3, 4, 5, 6, 7, 8, 9, if I have 10 chlorides, I should have 10 sodiums so that my compound is neutral. So positive and negative ions exist in a ratio determined by how many electrons are used. So another example, what if I have magnesium? Look at your periodic table. How many electrons will it lose? 2. So that would give it a +2 charge. If I have chlorine again, it has a -1 charge. Magnesium is going to have to bond with how many chlorine? 2 to make it balanced. So +2, -1, -1. The formula for magnesium chloride is MgCl2. So that ratio is determined by how many electrons move, how many are transferred. And then the repeating pattern of an ionic compound is called a crystal. So, like I said, most of your ionic compounds are salts, and they have a crystal structure, which means they're held very tightly together in a very organized pattern. And you can actually see that under a magnifying glass. And the strong attraction between your positive and negative is what holds it together. And that results in the formation of a new term. A crystal lattice, then, is your three-dimensional arrangement of the particles. So on a piece of paper or in your book, you're not going to see that it's three-dimensional. But when a crystal lattice is actually formed, it's going to come out in all 3 dimensions. When you have these crystals, the arrangement is also very important for how strong that bond is. So melting point, boiling point, and hardness of ionic compounds depends on how they're arranged. So if I look up here, which ionic compound is held together the best, for lack of better words? MgO. It is held together very tightly. It is very hard to melt. It melts at 2,852 degrees. It boils at 3,600 degrees. Sodium iodide would have the least amount or the least structure that's holding it together. So depending on how they're built and depending on how many electrons are transferred, it's going to affect physical properties of those compounds. So if I have a solid, this would be a crystal. It's organized very neatly. Ions are locked into position, and therefore they don't flow. And that's why it's not conductive. So when I stick my conductivity apparatus in a solid, it's not going to light up because these are organized, they're right by each other, they don't move, they stay in the same spot. Liquid ions, so if you melt most of these or you mix them with water, it allows the electrons to move. And when the electrons move, then it becomes conductive. And then it would light up the conductivity apparatus. This is extremely important inside of your body. Electrolytes. Gatorade's whole advertising commitment is based on ionic compounds. in your body, you need sodium ions, you need chlorine ions, you need magnesium, you need potassium. And you need it to move through your blood, basically. So electrolytes have to be in a liquid solution. So when you put salt on your French fries, by the time it gets into your body, it's going to be traveling through your blood, and it's going to separate back into sodium ions and chlorine ions, which is very important for muscle contractions and for your skeleton and nervous system. And these diagrams show what happened. So if you take a salt crystal and you hit it, it breaks apart because when you move these electrons and protons, they are going to line up and like charges repel, which is going to cause them to split apart. So whenever you put a hammer on a crystal, it's going to break apart. And pretty much the last section that we'll talk about, every time you form an ionic bond, that reaction is either going to absorb energy or release energy. Anything that absorbs energy is endothermic. Anything that releases energy is exothermic. And we'll talk more about that when we get into reactions. But every time a compound is formed, there's movement of energy. And when that happens, we get something called lattice energy. So the energy required to separate ions is called the lattice energy. It's directly related to the size of the ions. I'm assuming that might be a test question. The size of the ion determines the amount of energy. Smaller ions have closely spaced ionic charges, which means it's harder to separate, a higher energy. Electrostatic force, then, is inversely related to the distance between the opposite charges. The smaller the ion, the greater the attraction, the higher the energy. And then the value of the energy is also affected by the charge. Is it a positive ion or a negative ion? And you can see that here back in our same compounds that we had on the other table. MgO, which was the hardest to melt, the hardest to boil, has the highest lattice energy. It's very hard to break apart. If I look at NaI, sodium iodide was the weakest one on our other table. Notice its lattice energy is much smaller than the magnesium oxide. So the amount of energy it needs is directly related to how fast it'll melt, how fast it will boil, etc. And then last one, review. How do they form? What can you conclude? A lot of it's based on size. Some of it is based on how many electrons are gained and lost. Here, ionic bond formation is both. You can't have something endothermic without something else being exothermic. So it's either going to absorb heat or release heat. And then the rest is your vocab.